Ready? Okay, for walls, you're going to go into chapter 5 again. Okay? So the loading is in chapter 5. And you're going to go to 5-12. So if you go to page 5-12, you're going to see a table. Table 5-4. Okay? Table 5-4 has a nice little table that has loads per square foot based on 2 variables. The vertical column is rate of placement. The horizontal column is mix temperature. So it looks like we need, in order to find the load on the wall, we need R and T. Okay, why? Okay, we'll get into this pretty heavily when we start doing problems. But basically what you do is you put the concrete in the form and it starts to harden or set a little bit. Well, we have a way of reducing the force on the concrete formwork based on how hard the concrete is. If the concrete's a liquid, the horizontal force is exactly the weight of the concrete. As the concrete starts to set, it ends up reducing the horizontal thrust. And that's evidenced by when it gets hard, you can take the forms away and it stands up by itself. So you don't need anything then. So this is the table we're going to be using to develop a small sketch that will allow us to determine the load on the formwork. Okay, so this guy's pretty much a picture. If you look at the picture on page 512 on the right-hand column, just underneath the table, you can see a picture like what you're going to be developing. It just shows me how much force is pushing on the wall. And the force pushing on the wall dictates the size of the member. The more force, the bigger the member. So we'll be using table 5-4 in chapter 5 to get ourselves in a position. So rate of pour, that's the vertical height that you cover in a certain period of time. It's in feet per hour. So if I had a formwork and I started putting concrete in it, after 1 hour of pouring, I would measure how far up the wall I am, and that tells me how many feet in an hour I'm pouring. Faster I pour it, of course, the less time it has to set. Less time it has to set, the more force on the forms. So you as a project manager are going to have to worry about how fast you pour the concrete. If you're in a tight bind and you say, what the hell, we'll just heave it all in there, you may be pouring a slab instead of a wall. That system may just blow apart. So you need to get with the designer and make sure you understand what his design assumptions were so you don't go out there and blow those babies apart. The temperature, why does that have to worry about it? This is the temperature of the mix. The warmer the mix, the faster it sets. So if you have a real cold mix, it's going to stay liquid longer than a warmer mix. So the temperature of the mix influences greatly how fast the hydration process takes. And the faster the hydration, the quicker it becomes a solid, the less force there is on the formwork. So that's why these two guys are important. The rate of pour and the temperature of the mix. So that gets us basically through chapter number 4 and 5. There is one more thing we'll be covering, and that's struts. And what I think I'll do now is just go through the components quick. And once we've got the components, we'll break for this one. And then we're going to go ahead and start with slabs first, because it's the simplest one. And then we'll move on to wall forms. And then we'll finalize everything by putting struts on the wall forms. So if I drew this, sheathing. Okay, we're going to put the sheathing down. That's plywood or boards. That's where we pour the concrete against. So we've got sheathing. and this is slab. Okay, holding the sheathing is the joist. The joists are going to have a certain spacing. This is that L that's on these equations right here. That's how far apart those members can be. Okay? When we get into this, you're going to find out there's two ways of doing this. One is picking the member, picking the plywood, and then spacing the joists where it will hold the plywood. The other is we can go ahead and figure out a spacing that we like and then size the plywood to fit the spacing. So this is a two-pronged system. You can either find the spacing or you can find the size, and we'll do one of each. Okay, then we've got stringers. The stringers are holding up the joists. So we've got sheathing, we've got joists, we've got stringers. Okay, the stringers are holding up the joists. And if you're in a basement, look up above. You see the plywood, you see the joists, and then you'll see a beam of some sort. These are the brothers to the beams. This, once again, is L. Now this isn't, I'll call this L1. They're different. They don't have to be the same. I can have my, my stringers spaced at 5 foot apart and the joist spaced at 24 inches apart. Okay? And then underneath there we put a shore. So we're going to hold this thing up with a post, just like the steel beam in your basement. We call these shores. So we're going to go through this process and use these equations over and over and over again. That's why I say the W's change. So I'm going to design the sheathing first, so we go from where the concrete sits to the ground. Sheathing first, joist second, stringers third, shores last. So we'll go through that process, okay? So there's your members for your wall or your slab form system. Now, the wall isn't much different. I'm just going to turn this thing sideways and call them different names. So it's not a whole lot different than the house, except for once we get past the studs. We've got a couple of terms you're probably not familiar with. So now we're looking at wall. So I've got sheathing. And of course the sheathing is going to be standing vertical, and it's going to be at some distance apart. Okay? Now of course the distance apart is determined by your size of your wall ties, whether you want an 8-inch thick wall, a 10-inch thick wall, a 12-inch thick wall, or so on. So this is the sheathing. And one side is the same as the other, so we just have to worry about one side. What we do on one side, we'll do exactly the same on the other. Okay, then we've got studs. The studs are just like studs on a wall. They're spaced, and this is the L again. The L, L1. This is how far apart we put them. They'll be stacked, okay? So we got studs, and then to support the studs, we have wales. And the wales come in pairs. Okay? They come in pairs. And in between the wales, we will put a wall tie. And the wall tie then will have some sort of a device, a washer or something there, and we tighten them up. And when we tighten them up, that keeps the formwork at the right pitch all the way down, and the wall becomes a nice straight formed member. So these are called wales. So this is synonymous with the sheathing for the slab. This is synonymous with the joists. These are called studs. The joist. The wales are synonymous with the stringers. And now we've got to keep the wall straight. So if I turn this thing sideways, I've got my stud, I've got my wales. And then I got to keep the wall from moving and make sure it's nice and straight. So I've got a wall that's plumb instead of crooked. Now we will take and we'll put a member that goes on an angle. So we call it battered. Battered means it's on an angle. And this is a strut. And typically the two things that are associated with, let me get this over here. Two things associated with moving this wall. One is pouring the concrete. You pour it, some guy standing up top, on top of the formwork, it wiggles. So you gotta keep that. And the biggest one is what happens when you've got wind. Wind pushing against the wall and trying to knock it over. So we have one of these on each side. That takes care of the wind coming from both directions. So we'll be designing here, first of all, sheathing, second of all, stud, third of all, wales, fourth we'll be doing is the wall ties. And the last thing we'll be doing is the strut. So we've got three separate units right after this, subunits. One is slab formwork, two is wall formwork, and three is struts. And once we get through those three, we'll be all set. We're going to use chapter 6 now. So you're going to need all three chapters, 4, 5, and 6. 4 and 5 to gather data, and 6 to follow the examples so that you know how to go by it. And we're going to start with slabs, so we'll start the next class period designing a slab formwork system, and we'll be going through it iteration by iteration by iteration until we get from sheathing all the way to the shores. So that takes care of this one.